Hey students, welcome back to another tutorial lesson from the EDEXCEL Institute of Mathematics Education. My name is Akeen, your math instructor, and in today's video we're going to be looking at the SINE rules application. Now, in a previous tutorial video I had done just a few days ago, we had looked at the application of the cosine rule. Now, both the cosine and the sine rule work side by side because they are both used to find the length of a missing side and or the size of a missing angle in a non-right angled triangle. So you definitely want to check that tutorial out, looking at both scenarios in which the cosine rule is applicable, because that's exactly what we're going to be doing in this video. We're going to be looking at two more scenarios in which the sine rule is applied. Right now, if this is the first time here on the channel, contents made here are mainly built in regards to students completing the exams under the CSEC, CSEC, CCSLC, SEA, and or EDEXCEL exams. Contents are also done for math in general, but those curriculums are the main focus. Alright, so definitely go ahead and subscribe to the channel and leave a like if the videos are of any value to you. Share this out to your math communities, and of course do not forget to turn on the post notification bell. Let's jump right into the video and have a look at what is the sine rule. Now, on screen here, as you can see, the sine rule is used in the similar way to that of the cosine rule, where, as mentioned before in the intro, you are using the formula to find the length of a side or the size of an angle in a non-right angle triangle. Now, I'm not going to be proving the sine rule to you. That's probably going to be a video that I'll be doing in the future, the proof of the sine rule. I'm simply going to be explaining the scenario that will present itself for the application of the sine rule. Now, the sine rule it's a comparison, or it's a ratio between the angle and its corresponding side. Now, as you can see here, we have the formula sine of the angle A divided by its length equals the sine of the angle B divided by its corresponding length, and that's going to be equal to sine of the angle C divided by its corresponding length. Now, at the CSEC level, you might find that this formula is flipped, so you'll find that we write A divided by the sine of capital A, that's the sine of the angle, is equal to the length B divided by the sine of the angle B, and that's equal to C divided by the sine of angle C. So both formulas are applicable, both formulas will produce the same result. Alright, so this is the one that we are going to be using. Okay, now the comparison is always going to be made between two sides. So we're never going to be making a comparison between all three sides simultaneously. So majority of the time you're going to find that we tend to use this aspect of the formula mainly here. Okay, but just in case that side C comes into play, then we might be able to compare side C to side A or side C to side B. Alright, but typically we just keep it very simple and we use side A compared to side B. Please note that your diagram may not necessarily be labeled A, B, and C. It may be labeled with different letters. Hence, we are simply going to be the one that will assign small a and capital A to the necessary angles. Okay, now let's have a look at the first scenario. And so the first scenario here states that in order for us to find the length of a side, what is it that must be given to us? Well, according to the information here is that you must be provided with one side and two angles. Does that mean I can give you any side and any two angles? Well, not necessarily. You must be provided with one side and two angles, but one of the angle must be opposite or facing one of the side. So let's say, for example, I can just look at this blank triangle here, this blank scaling triangle, or whatever the triangle this may be. I can simply just say, for example, this here is side A. So that means I must be provided with an angle here, that is angle A. And so clearly, if it is that I am provided with, say, this angle here, then that would naturally mean that I'll be finding the side X down here. So let's see, we are provided with a side and we are provided with an angle facing or opposite one of the side, and we are looking for a side X, which should be represented by B, small b, and we are provided with the angle that is facing the side that we're looking for. So that is the scenario in which that must be provided. That is for us to find the length. So simply finding a length, we must be given two angles, but one of the two angles that are provided must be facing the side that we are provided with. So hopefully that makes sense to you. Let's see if this can be matched to an actual question. Does the scenario for cosine rule matches here? Let's see. We are looking for side X. So we are indeed provided with the angle that is in front of X, and we are provided with another supporting angle facing the side that's given. So we are provided with two angles with one of the side facing one of the given angle, and we are finding a third side. So that is how we know for certain that we're going to be using the sine rule. Now definitely check the video out on the cosine rules application, because then it will make a lot more sense as to the cosine rule compared to that of the sine rule. So we can proceed right here and say A divided by side A, or sine of angle A, is equal to B divided by the sine of angle B. So clearly we are going to have to be the one to assign the variable to the information on the diagram. Now you can make a choice, it really doesn't matter, right? You can simply, let's just say we're going to be assigning the letter A to the side that we're looking for. Then clearly the angle that is facing the side we're looking for must be capital A. And naturally the side that's given to us would be B. So obviously the angle facing it would be capital B. And that is simply how we assign our variables to our diagram, given that the triangle is not named with the standardized letters. So we can proceed here and we can go right ahead and we can say so A would have been X here divided by the sine of the angle facing X would have been 80 degrees, and that's going to be equal to B, which is 7, divided by the sine of the angle that is facing 7, which is 60 degrees. So we can hop onto our calculators now and we can simply say X divided by, and we're going to find the sine of 80 degrees. So sine of 80, please ensure that your calculator is programmed in the degree. So that's 0.984 and that's equal to 7 divided by, well, pardon me, let's just find the sine of 60 first. Let's take it a step at a time, guys. That's 7 divided by 0.8660. Or 0.86 is fine. Okay, so here now we can simply do a cross multiplication. So we can simply cross multiply here by saying x multiplied by 0.8660, which in this case here would have been 0.8660x. Let's take out that 0. Let's put an x here. And that's going to be equal to the cross multiplication here. We're going to multiply 7 by 0.984. We could just write that down if you want to. So that's going to be equal to 7 times 0.984. Alright, so we're just taking it step at a time, guys, for the first example. So we're gonna have 0.866x, and that's gonna be equal to 7 multiplied by 0.984. Hopefully you guys are working with me at the same time. That is 6.89 rounded off. Alright, let's just write the full value, 6.888. So now simply dividing both sides by 0.866, we end up with 6.888 divided by 0.866. So we'll end up with an answer that the length here is equal to 7.95 rounded off, or x is approximately equal to 8 units. In this case, there is no unit of measurement, so we just say simply 8. Okay, so that's just the procedure in which we have to go about trying to find the side. Now, there's many ways to skip out a couple of the steps here, and a lot of my students that have actually learned this would have learned that we can skip out the cross multiplication method here and hop to the answer like about here or here. So whatever works for you, you can do it. But this is generally what we have to do to get our answer. Alright, now let's move on to another example. We're going to add a little speed to it and take out some of the steps. Alright, so once again, let us look to see if the SINE rule criteria have been met. So we are in fact looking for, let's say for example, in this case we could be looking for B, or we could be looking for C. Now I'm thinking most likely that we are looking for B. And why do I think so? Because we are not provided with the angle that is facing C. But based on the setup of this question, we could actually calculate the angle of C. We could, because the sum of the interior angles of a triangle measures 180. So if I wanted to calculate the angle here, then this would simply be 180 take away the sum of 48 and 81. And so this angle here would have been calculated to be 51 degrees if I needed to find that angle. So now that I know what this angle is, I have an option. I can choose to find the side B, or I can choose to find the side C. Now, just for the purpose of the video, we're just going to be finding the side B. Okay, so let's see if the criteria has been met. Now, in order for us to find a side on a non-right angle triangle using the SINE rule, then the side that we're trying to find, we must be provided with the angle that is in front of that side. And also we must be provided with another side and the angle supporting that side, or the angle that is opposite to that side. So yes, the criteria has been met, so we know right away that we can use the sine rule. So we could simply say here that A divided by the sine of the angle facing A is equal to B divided by the sine of the angle facing B. Alright, so with that said, then it's time for us to assign our variable. Now we are fortunate enough that this diagram is labeled A, B, and C, and it's not only labeled A, B, and C, but it's also labeled correctly, because you can see here that small a is facing capital A, small c is facing capital C, small b is facing capital B. So we're in the safe here. We don't have to really assign a letter. But in the event that you end up with a blank diagram, or a diagram named with a different variable, then we may have to be the one to assign the A, B, and or C. So right away we can see here that A is 10.8 divided by the sine of 81. And that's going to be equivalent to B, which is going to be the unknown side. We could call the unknown side small b if we wanted to, or we could call it AC, because AC is the length that is indicated by B. So let's just use B here, divided by the sine of the angle facing small b, which is 48. So now let's see here. We can go on our calculators and we can find the sine of 81. We will end up with 10.8 divided by 0.987. Well, it's actually 0.988 rounded off, but let's just work with 0.987. And that's going to be B divided by the sine of 48. That's 0.743. So now, the last example I showed you that you have to cross multiply, but we can simply go ahead and divide 10.8 by 0.987. And so we end up with 10.94. That's to the left side, and that's going to be equivalent to B divided by 0.743. Now, very simply here to get the answer, we simply multiply, because the unknown variable is at the top. So if it's in the numerator, we simply cross multiply to get our answer. So I think this is a little bit shorter. So therefore B would have been equal to approximately 8.13. So B is equal to 8.13. Once you multiply 10.94 by 0.743, you should get an approximate answer of 8.13. In this case, it's going to be centimeter. All right. Now, what I want you guys to do for me is to go ahead and find the side C by using the sine rule. Okay. So the comparison for this is going to be made between A over the sine of capital A, and you're going to be comparing it to C divided by the sine of capital C. All right, so you're making a comparison between the side A and its angle with the side C and its angle, and the angle facing it. And remember that we had calculated the angle 51. So make that calculation, leave your answer down in the comment section. I will let you know if you are correct. Okay. All right, good. So hopefully you guys get a clear understanding of how to use the sine rule to find the length of a missing side. Now, we're going to be using the sine rule naturally now to find the length, not just the length, pardon me, but we're going to be using it to find the size of an angle. So yes, this is scenario number 2. All right, and this should have been size. Okay, right here where I have side, it should be size. So scenario number 2 here is that to find the size of an angle, you must be provided with 2 sides or 2 lengths and 1 angle. Is the case we're just provided with any 2 lengths and any angle? Well, like scenario number 1, no, it has to be very specific. So we must be provided with 2 lengths, but one of the lengths that we are provided with, it must be facing the angle that was given. So let's say for argument's sake that we are looking for the angle here that is marked by x degrees. Then we must be provided with a length that is facing that missing angle. So we must therefore be provided with, say for example, length A. Naturally now, we must be provided with another length and its supporting angle. So we could be provided with, say for example, this angle and this length here. We could call it B and capital B. Or we could have been provided with, say for example, the angle here, which we can therefore call C, and we must be provided with the side facing C, which is small c. Alright, so it depends. We just know that for certain, to find the angle, you must be provided with the side in front of the angle, and you must be provided with another supporting side and its angle. Hopefully that is clear. Let's have a look at this example to see if the SINE rule can be applied. So I didn't specify here, but I'm going to say let's find, well, I don't have to because this is obviously going to be the angle that we are interested in finding. Now, how do I know that this is the angle that we are interested in finding? Not only did I construct the question, but you can see here that we are not provided with the angle C nor the side facing angle C. So we know that that will not be a part of our calculation. But you can see here that we are in fact provided with 8 feet, the distance between B and C, but we are not provided with the angle in front of the 8 feet. So we are provided with a side, but the angle in front is missing. That is how I know that this is the angle that I'm looking for. And you can see here that I have a supporting side and the angle facing the supporting side. So therefore, we can indicate here that the angle that we're looking for is marked by, say, x degrees. Or you could just simply say angle A. Okay, so if that is the case, then let's label our sides. Now, once again, we are fortunate enough that the diagram is labeled A, B, and C. So we could utilize this here. We could simply say, okay, this is angle A, so this would be small a. And this is angle B, so this would be small b. So we can utilize the naming of the diagram. So here we go. A divided by the sine of angle A. B divided by the sine of angle B. So what we're looking for here, guys, is that A is 8 feet. We don't need to put the unit of measurement for now until we get our answer. Divided by the sine of the angle facing it, which would have been the angle marked by x degrees. And that's going to be equal to B, which we have assigned to be 5 feet, divided by the angle facing the 5 feet, which should have been 37 degrees. So now you can see here that 8 will divide the sine of the angle that is marked by x degrees. Obviously, we don't know what that is. And so 5 will be divided by, and we can proceed on the calculator to finding the sine of 37 degrees. So we would have attained a result of 0.601. Once again, if you choose to cross multiply the method I showed you earlier in scenario number 1, you could, but just try to make this quick for the purpose of the video. Simply divide 5 by 0.601 and we would end up with another part of the equation, which is sine of 8 divided by the sine of x is equal to 8.32 rounded off, but we can just write 8.319. Right? So now we are finding out that the unknown variable, which is the angle we're looking for, is in the denominator. So what happens when using this method here, what happens when our variable or our unknown quantity is in the denominator? Well, we do a swap. So we are going to divide. We're simply going to swap the 8.319 with the sine x. So we're going to have here 8 divided by 8.319, and that's going to be equal to sine x degrees. So we do a swap whenever the unknown variable is in the denominator. So let's go on our calculators. 8 divided by 8.319, and we should end up with 0.961. That's equal to sine x degrees. Now we're looking for the degree x degree, so we're gonna have to find the inverse of the angle. This is what we call arc sine x. Now for most calculators, you should be able to hit the button 2nd second function, or the button marked by shift. That's usually to the top left hand corner of your calculator. If you see that, then you can hit second function and hit the function sine. You should see that x degrees will be equal to the sine raised to the -1. Alright, so if you see that, of course, leave a like. That means you're working with me. And we're going to find the inverse sine of 0.961. Do not forget to hit that like button, guys, if you haven't done so already. It helps the video to go out. I need at least 50 likes on this video. So here we go, guys. So we're going to hit second function sine 0.961, and we're going to get that x is equal to 73, or I should say approximately 74 degrees. Alright, so x is approximately equal to 74 degrees because the actual answer is 73.94. Alright, so that is one example of how to apply the sine rule. Alright, let's do another example. One example is never enough. I've oftentimes tell my students this. So once you do the first example, that's literally to help you to understand the process, the steps, certain key clues in the question. Then now the second example is where you're going to really test yourself on your own. So now for this particular example, we're going to be looking at calculating the size of the obtuse angle VUW. Oftentimes you're going to find that on the CSEC exam paper, they tend to name the angle with 3 letters. Now if you're not familiar with what is the angle VUW, then the angle's location is always at the letter that is in the middle. And not only did they didn't have to really say VUW, because they did say obtuse angle, and you guys should know that an obtuse angle is an angle that measures more than 90 degrees but less than 180. Clearly, this angle could never be beyond 90, and naturally if you were to construct a 90-degree here, then you'll find that an extra piece of angle is over. So if this is 90, then naturally you'll find that this angle here is greater than 90. So two ways in which they gave away the question here. They said that it's the obtuse angle, which this is the only angle that apparently seems to be obtuse, and they did specifically say that the angle is located at U. Now let's check to see if the criteria for the sine rule has been met. We already know that the criteria for the cosine rule has not been met because we are provided with two sides, but we aren't provided with the angle between the two sides. Definitely check out the video on the cosine rules application. Then this will make a lot more sense to you if this is the first time here watching my content. So we've established that. Let's go ahead now, and we know for certain that the rule of thumb here, or the rule to be used here, is A divided by the sine of capital A, and that's equal to B divided by the sine of capital B. Now I've been mentioning it to you guys that the diagram may not necessarily be labeled in our favor where we are dealing with A, B, and C. So here, this is just a case that we are going to have to be the one to assign the variable used in the equation to match what information provided on the diagram for us. Now, I mean, if you want to be, I guess, proactive and you want to test yourselves and you want to try to redesign a formula, then you could simply say, all right, small u over the sine of the angle marked by U, capital U, and that's going to be equal to small v over the sine of the angle facing capital V. Or it wouldn't be V, pardon me. Yes, it would be V. Yes, it would be V. That's correct. All right. So you can see here that I am not provided with the angle W, nor am I provided with the side facing angle W. So I know that W would not be a part of my comparison. But surely, guys, I don't think that you need to go to that extent where you have to recreate the formula. I think it's just a simple case where you simply just assign the letter A to a side, like I'm doing here. I'm just going to be assigning here A, and you're going to be seeing here that the angle that is in front of side A is capital A. Alright, that's going to be 32. And here, we're going to be assigning B here, small b, and then obviously the angle marked by U will be indicated by this angle B. Alright, so here we go. Then we will have 5.6 divided by the sine of the angle facing 5.6, which in this case is 32. And that's going to be equal to B, which is 7.3, divided by the sine of the angle facing 7.3, which we have indicated to be B. Or in this case, we can say it's the angle VUW. Alright, so it's the sine of the angle VUW. Alright, but just for simplicity, let's just use B because B is representing the angle VUW. Alright, so let's go on our calculators. We're going to find the sine of 32. We're going to find that this is 5.6 divided by 0.529 or 0.53 rounded off. 0.530, but let's just use 0.529. And that's going to be equal to 7.3 over the, obviously we don't know what sine B is, that's what we're looking for. So 5.6 divided by 0.529, that gives me a result of 10.59 rounded off, 10.586. I like to use 3 decimal places, guys. And that's going to be 7.3 over the sine of angle B. So here we are finding now again that the unknown variable, the angle, is in the denominator, so we're going to be doing a swap. So we're going to be swapping the 10.586 with sine B, and that's going to be 7.3 divided by 10.586. So that's 7.3 divided by 10.586. That will give us a result that sine B is equal to 0.689 or 0.690 rounded off, 0.690 rounded off. All right. And so once again, we're going to have to find the arc sine to find the angle. So the angle B is equal to sine raised to the minus 1, 0.690. So shift our second function, the sine function follows. So that's shift sine function, sine raised to the minus 1, 0.690 rounded off. We are going to find that the angle indicated by B is approximately equal to 44 degrees. 43.6, 44 degrees. All right. So those are two nice examples on how to apply the sine rule. All right. Now, these two rules are going to be vitally important because on screen here you can see that my next tutorial video is going to be on bearings. And that's going to be a very interesting video, so you definitely want to subscribe to the channel. So far, if you have gotten some value and you're clear on the application of the sine rule along with the cosine rule, leave me a like. Do not forget to turn on the notification bell so that you can be notified whenever the video is posted on a weekly basis. Share this out to your math communities, friends, whoever it is that are doing exams and need some help, extra help. Definitely share this out. Leave your questions, suggestions, comments, and positive feedback, preferably in the comment section below. Check in the description box, you'll find links to other tutorial videos that have been made on this channel. And of course, hopefully this channel will help you to do a lot more or a lot better on your weekly exams, quizzes, and or major exams. All right, so with that said, we're going to be taking this video to the end. Bearings is our next tutorial video. Definitely look out for that. Take care, guys. See you in the next one.